Okay, let's go ahead and get started here with 6.2, multiplying and dividing rational expressions. Take notes and text me if you have any questions while you're watching this video. Okay, so 6.2, multiplying and dividing rational expressions. Okay. All right, so before we take a look at multiplying and dividing rational expressions, let's just kind of do a quick review on multiplying and dividing just regular numbers, fraction numbers, okay? All right, so let's take a look here at multiplication. So if you remember, if you had something like this, 10 over 12 times 18 over 5. So if you remember here, you went ahead and cross-canceled, right? So like here, 10 and 5 have 5 in common. Okay, so they have a common factor 5. So I can go ahead and cancel that, right? And then we see here that 2 and 12 have common factor 2. So I'm going to go ahead and cancel that. So 2 goes here once. 2 goes here 6 times. Okay. But then I also see that 6 and 18 cross cancel. Okay. So 6 goes here once and 6 goes here 3 times. And I can see here 1 times 3 across the top is 1 times 3, which is 3. And then across the bottom, 1 times 1 is 1. And so the answer is 3. Okay. So it's kind of like a big simplify problem. So anything in the numerator can cancel with anything in the denominator. So that's why we're able to cancel like this, because you have something on top, something on the bottom. You can cancel like this, something on top, something with the bottom. And then we were able to cancel like this, because you have a top and a bottom. You cannot cancel this way. You know, you don't have a top and a bottom. It's just numerator and numerator. Okay, because we're doing what we do with simplifying, where if you have anything over itself, right, it equals 1. Okay, so now let's take a look at rational expressions. So the same thing is going to happen here. Suppose that I have these polynomials and then I factor them, right? So the key thing here, just like in 6.1, is that you're going to have to factor and cancel. So let's suppose I have some polynomials. I go ahead and factor them, and let's suppose that they factor out like this. Suppose they factor out like that, and like this, and I'm going to multiply with another polynomial that factors out like that, and another one that factors out like this. Okay, so just like here, when we had just numbers, we can go ahead and cancel anything in the numerators with anything in the denominators that match. Okay. All right, so we see we have an x plus 3 numerator denominator. We have x plus 1 numerator denominator. And that looks like that's about it. Okay, so again, here you cannot cancel these because that's numerator, numerator. Okay, so we end up with x minus 1 squared over x minus 2, x plus 5. Okay, to me, this would be fine if you wrote your answer like this. Your homework online, they might want you to multiply these out. So just be aware that if it doesn't take this answer, then you have to multiply it out. Okay. All right, and let's also recall division of just regular numerical fractions. So let's suppose that we have this 10 over 12 divided by 6 over 5. Okay. And maybe you guys remember this here. We're going to go ahead and keep that fraction. So we're going to keep it as 10 over 12. But we're going to go ahead and flip this one. So we're going to turn it into 5 over 6. And then we're going to go ahead and change that division into a multiplication. Okay, KFC. All right, so 10 over 12. We're going to keep that one. We're going to flip this one, and we change this to multiplication. Okay, and then with multiplication, you check to see if you can cancel anything. So over here, they have 2 in common. So we get 5 here and a 6 here. And that is it. So we get 25 over 36. Okay. So now with rational expressions, you're going to follow the same process. You're going to go ahead and keep the first fraction. You're going to flip that second fraction, and you're going to change it to multiplication. Okay, so let's have a look. So suppose that I have this, x plus 3, x minus 1, right? This is nice because I'm going to have it all factored out for you. Okay, so x minus 2, x plus 1. The examples will do, they won't be factored. We'll factor them together. Okay, x minus 4, x plus 3, x minus 2, x plus 2. Okay, so before you can do any canceling here, you do have to do your changes. Okay, so we're going to go ahead and keep this, right? So same process. We're going to go ahead and keep this. We're going to go ahead and flip that. We're going to change that to multiplication. Okay? All right, so keeping this first fraction the same. Changing this to multiplication and flipping this one. And then we go ahead and cancel if we can. Okay? So let's see. We have x plus 3 in the numerator and the denominator. So they cancel. We have x minus 2 in the numerator and the denominator. Okay, and that looks like that is about it. So we end up with x minus 1, x plus 2, all over x plus 1, x minus 4. Okay? And again, you might have to multiply this out if it doesn't take your answers in factored form. Okay? All right, so if you understood that, that is really basically it. So I'm going to go ahead and work out some examples if you're still a little confused. We're going to do some examples where we need to factor. So if you feel like, oh, you're a little bit weak with factoring and you want to kind of practice that, you can kind of stick around and we'll work through it. Okay? All right. Okay, so if you're done, then if you understood that, then you're actually good to go if you don't need to see any examples. All right. The rest of you who are sticking around, let's go ahead and take a look at this first example. Let's go ahead and simplify. Actually, let's call it A. All right, so let's go ahead and simplify x cubed plus 8. Perfect cubes, so hopefully you have that all memorized now. 4x plus 4 divided by x squared minus 2x plus 4, 2x squared minus 2. Okay? So we are going to keep this, flip this, change that. Okay? So x cubed plus 8 over 4x plus 4 times 2x squared minus 2 over x squared minus 2x plus 4. Okay? All right, so now let's go ahead and do our factoring. So right here we have perfect cubes. And remember, identify what's being cubed, and that will make your binomial. And then from your binomial, you can create your trinomial, right? So we have a binomial and then a trinomial. Okay, so if we identify what's being cubed here, x is being cubed and 2 is being cubed. So our binomial will be x plus 2. And then to get our trinomial, remember it's square, take their product, square. Okay, so square, and then it's going to be subtraction, product, and then addition, square. Square, product, square. Okay, down below here in the numerator, it's common factor 4, and we'll have that. Okay. Up here, we're going to go ahead and factor out a 2, common factor. Okay, but we can still factor the x squared minus 1, right? So that's perfect squares. So let me go ahead and factor that as x plus 1, x minus 1. Okay, and then down below here is one where we have the trinomial and we have to guess the binomial. So something times something to make x squared, x times x. We want positive 4, so the signs have to be the same. This tells me they'll both be negative. And 1 and 4 doesn't work. 2 and 2 doesn't work. So this is not factorable. All right, so we'll leave it. That always reminds me of like dog owners. Leave it. Okay, anyway. I love dogs. Okay, so here, x squared minus 2x plus 4 cancels with that. Right? 1's in the numerator, 1 is in the denominator. We also have an x plus 1. Okay. And then we also have these numbers. Oftentimes students will forget the numbers, so don't forget the numbers, 2 and 4. So 1, 2. And that looks like that is about it. So in the numerator, we are left with x plus 2 times x minus 1. And in the denominator, we're left with 2. Okay? And again, make sure if it doesn't take your answer, try multiplying it out. Okay, let's see. Let's do one of these. A squared plus a minus 56. A squared minus 49 times a squared minus a minus 56. A squared minus 64. Okay. All right, so this here is not division, so we don't have to do the KFC. Everything just remains the same. Okay, so you do the KFC only when it's division. Okay. All right, so let's go ahead and factor everything. All right, so up here, it's the trinomial, so we have to figure out the binomial to make this. So a times a to make a squared. And then I want negative 56, so my signs have to be different. And we're going to go with 7 times 8 I'll make the 8 positive, the 7 negative, and that way I get 1a for the middle. Okay, and then here, this one is perfect squares, so it's a plus 7, a minus 7. So is this one, so let's just do this one, perfect squares, a plus 8, a minus 8. Okay, perfect squares are fun. Okay, and then up here, this is very similar to the other one. A times A, signs have to be different, but now we want -1, so I'll put the 8 here and the 7 here. Okay. All right, let's see, what can we cancel? A minus 7s, A plus 7s, A minus 8, A plus 8. So what's our answer? Hopefully you said 1, not 0. Okay. 1. Okay, let's see what else we got here. Let's do this one. Was that an A or a B? That was B. Example B. So example C, let's do x cubed minus 8 over 9x minus 9 divided by x squared plus 2x plus 4 over 3x squared minus 3x. Okay, so this one is division, so we have to do our K of C, keep flip change. So we're going to go ahead and keep change flip. Okay. All right, so up here we have perfect cubes again. Okay, so perfect cubes, you factors out to a binomial and a trinomial. Okay, so identify what's being cubed. So here x is being cubed and here 2 is being cubed. So that's going to make up your binomial, x minus 2. And now we can come up with our trinomial because it's just square, product, square. So square, and then plus, product, and then square. Okay. And then down below, we have common factor 9. So I'll factor out a 9. I'll be left with x minus 1. Up here, we have common factor 3 and an x. So then we'll be left with x minus 1. And then down below here, we're going to have to do x times x to make x squared. Then we want positive 4. The signs will be the same. This tells me they'll both be positive. And again, this one doesn't factor. Okay. Fooled again. Okay. So this one and this one cancel. X minus 1 cancel. And this little 3 here cancels with the 9. Okay, so we are left with, I like to put the x first, and then x minus 2, and then 3. You don't have to, but that's the way I like to write it. Okay, let's see. Let's do this one, this next example. All right, suppose I have this one, b cubed minus 4b divided by over x minus 1 divided by b minus 2. Okay. All right. So we have, this is division. So we do have to do our K of C here. Okay. So we're going to go ahead and keep this one. We're going to change this to multiplication. And we have to flip this one. So just like with numbers, if you have like something like this, Okay, suppose you have something like that, right? So here, if you have 5, you can always turn it into a fraction by putting it over 1. Okay, so same thing over here. This b minus 2, you can put it over 1. Okay, so here we have to flip it, take the reciprocal, and this is what we get. Okay, all right, so we did our KFC. We're going to go ahead and factor everything. So up here we have b in common, and that's b squared minus 4, x minus 1, 1 over b minus 2. All right, but we have perfect squares here. Okay, so we can go ahead and factor that out as b plus 2b minus 2. So let's go ahead and fix that. B plus 2, b minus 2. All right, so here they cancel out, and unfortunately that's it. Okay, so we have b plus 2 in the numerator, and then x minus 1 in the denominator. Okay? All right, so just be careful right here. When you don't see a fraction, you can always put it over 1. Okay? All right, let's do one more example here. And this one has division and multiplication in it. Okay? So let's have a look. I like these, which means a high chance of showing up on the test. Here's your division. 2x squared minus 5x minus 3. And here's your multiplication. X squared minus 2x minus 3. Okay, so right over here is your division. So we're going to keep this, flip this one, and we're going to change that. Okay, so we're going to keep change, flip. Okay, and then we're going to bring down this third fraction. Okay, so we're just going to bring this down. We don't have to flip it. It's multiplication. Let's make sure we write 2, not 3. Okay, all right, so now everything's in the right place. So now we can go ahead and factor, and this could take a while. All right, x times x to make x squared. We want negative, so the signs have to be different. There's only one way to make 3. 3 times 1. 3 here, 1 there, and we end up with positive 2x for the middle. This one over here, okay, so I'm going to go with 3x and 2x. Signs have to be the same, so plus plus, 1 times 1. And this gives me 3x, 2x, that's 5x, so that is correct. Okay, pretty good so far. Up here, 2x times x, signs have to be different. Only one way to make 3 times 1, so we're to put the 3 here or here. And it looks like, if I do the math in my head, looks like the 3 will need to go here. And that will give us negative 5 for the middle. Okay. And then over here, I can anticipate this. When I factor out the 2, I'll still have perfect squares. Watch, 2 times x squared minus 1, right? So here, I'll do x plus 1, x minus 1 for the perfect difference of squares. Okay. All right, let's do this third fraction. Okay, so here in this third fraction, I notice that they have 2 in common. Okay, So here, I'm going to erase this so it doesn't distract us. Okay, so here, I notice that they have 2 in common, so I'm going to do that first. And then I'll factor that trinomial down here. All right, so 3x, 1x. Signs have to be different, 1 and 1. Negative 3 plus 1 is negative 2, so the signs are in the wrong place. This one needs to be negative. This one is positive. All right, and then down below, we have x times x. Signs have to be different. 3 and 1, so where to put the 3? Here. Okay, now once you have everything factored, again, it becomes one huge simplified problem. So you can cancel a factor in the numerator with a factor in the denominator. Okay, so let's get started. Are there any x plus 3's down below? No. X minus 1's? Yes, I see one down here. Okay, so remember, something from it has to be a numerator and a denominator. Okay. All right. Are there any 2x plus 1's? Yes. Any x minus 3's in the denominator? Yes. Okay. 2? Yes. Okay. 3x minus 1? No. So that's going to stay. X plus 1? Yes. Okay. Or you could have used this one too. All right, so what's left? In the numerator, I have an x plus 3, and I have a 3x minus 1. In the denominator, I have a 3x plus 1, and I have an x plus 1. Okay? So that is it. Again, if they don't take your factored answer, just multiply everything out. Okay? All right, so that is pretty much it. And this is about as difficult as they get. So, and like I said, I like this problem. So I'm going to try to put something like this one on the test. Okay. All right. So that's about it. If you have any questions, make sure you message me or you email me. Make sure you keep up with the homework. I'll see you guys next time. Well, not really, but you know what I mean.